session on vector analysis, we will discuss about vector integration, in which line integral, surface integral and volume integrals of a vector field. Vector integration. First, line integral of a vector field. A line integral is integral in which the function to be integrated is determined along the curve in the coordinate system. Means if the function is integrated and is determined along the curve in the coordinate system, such an integral is known as a line integral of a vector field. The function which is to be determined or integrated may be either a scalar field or a vector field. We can integrate a scalar valued function or vector valued function along the curve. The value of the line integral may be evaluated adding all the values of the points on the vector field. A line integral is an expression of the form of line integral of f dl from A point to B point on the prescribed path or on the line, where f is the vector function and dl is the infinitesimal displacement vector, and the integral is to be carried out along the prescribed path P from point A to point B. If the path is the closed loop, then expression can be written as line integral of f dl. If the path is closed loop, then along the closed loop integral can be written as line integral of f dl. Applications of line integrals. So line integral is having number of applications in the vector calculus and also used to calculate the surface areas in the three-dimensional planes. Line integral is used to calculate mass of the wire, and it is used in Ampere's law to compute the magnetic field around the conductor, and line integral helps to calculate the work done by the force. So these are some of the applications of the line integral. Next is the surface integral of a vector field. In the vector calculus, the surface integral is the generalization of multiple integrals to integration over the surfaces. Sometimes the surface integral is known as the double integral. For any given surface, we can integrate over the surface either in the scalar field or in the vector field. In the scalar field, the function returns to the scalar value, and in the vector field, the function returns to the vector value. There are two types of surface integrals. One is the surface integral of a scalar function and surface integral of a vector function. The surface integral of a scalar function is the simple generalization of double integral. The surface integral is an expression which is of the form of surface integral of f ds, where f is vector function and the integral is over the specified surface, where ds is infinitesimal patch of area with direction perpendicular to the surface. If the surface is closed forming balloon, then expression is of the form of surface integral of f ds. Applications of surface integrals. Surface integral is having number of applications in the areas of science and in engineering. Some of the applications of surface integrals in vector calculus are: it can be used to determine pressure and gravitational force. In electrostatic, it is used to compute the electric field, and it is used to find mass of the cell, used to calculate the moment of inertia, and also it helps to determine the electric charge distributed over the surface. These are the some of the applications of the surface integral. Volume integral of a vector field. The volume integral is an expression which is of the form of volume integral of a dv, where a is a scalar function, dv is the infinitesimal volume element. In Cartesian coordinate system, if v is a vector, dv is equal to dx, dy, dz, which is the volume. Then vector v is equal to vx, x cap, plus vy, y cap, plus vz, z cap. Then we can write the volume integral as volume integral of v dv is equal to volume integral of vx, x cap, plus vy, y cap, plus vz, z cap into dv. This volume integral can also be written as volume integral of v dv is equal to x cap volume integral of vx dv plus y cap volume integral of vy dv plus z cap volume integral of vz dv. This is the volume integral in the Cartesian coordinate system, where x cap, y cap and z cap are the unit vectors and they are constants, therefore they are taken outside the volume integral. This is about volume integral of a vector field. In this session, up to now we discussed about the line integral. Line integral is an expression of the form of line integral of f dl from A point to B point along the curve or along the line. The surface integral is an expression of the form of surface integral of f ds through the surface ds. The volume integral is an expression of the form of volume integral of A dv over the volume V. Thank you.